So this will be my competency for 3.1, which is drawing a free body diagram of a rigid object. So here we have a wonderfully drawn pipe, basically through or whatever I guess you want to call it, a cylinder through a couple of like bearings here, just to hold them in place. But it can, we'll get to it in a minute, kind of how it can move. But what we want to do when we're drawing a free body diagram of these objects is we're gonna basically isolate what the object we want to look at. So in this case, it'll be this cylinder. So we will draw it down here. And then everything acting on it or preventing it from moving, things like that. So like if there's a force, like right here, then we'll draw all the forces on it, but we'll also draw all the constraints on it. So to do that, we will, so kind of we're going to look at it. So we'll just isolate this. So that means that these bearings, whatever you want to call them, kind of clamps holding it together, they're still going to allow it to slide. So we won't put that in, but as we kind of look at it, so I guess we'll start with this one, and this will make a little more sense once we kind of go through it. If you look at this and think of it as kind of a cylinder through, you know, some sort of bearing like this, it obviously can't move up and down because it's flush. So if we look at this in like the X, Y, and Z direction, like that, sure. If we look at it like that, there we go. It can't move in the Z or the Y, so the Y is coming towards us out of the board, the Z is going up, the X is that way. It can't move in the Y or the Z, so we would draw constraints there. So we would draw forces acting on it to prevent it from moving there. And we would draw another one, kind of not like that, kind of towards us, almost just preventing it from moving. I should have drawn this a little bit off-centered so we could see it better, but essentially it's preventing it from going up or coming this way. So on this plane here or on this plane here, it cannot move. So we draw those as forces. Now we'll have the same thing over here. We'll have a force here acting on it, preventing it. We'll have one kind of at an angle, basically coming into the board from this direction. I just didn't draw that free body diagram super well, so that's another thing to consider. When you're drawing it, is maybe shift it a little bit just so it's easier and it makes a little more sense to you. So we'll draw those, and then we'll also draw this force here, because that is also acting on it. And as we kind of do that, now we can say, okay, maybe there's if I had a bit of a different object, or say this was maybe like there was a hinge here of some kind, and maybe this wasn't, like these weren't here, and it was just like a cylinder or beam with a hinge down here, then you'll also evaluate moments around it. Now at this one, obviously there's no moments here because it can't, if you had a point here, it can't turn, I mean really anywhere, it can't rotate. It could rotate like this, so you wouldn't have to worry about that. But you would, I mean, you draw moments here and just say like a moment around this point, if you call that point A, I mean that would also be there'd be a moment there, just prevent it at this point, preventing it from rotating like this around there. Excuse me, if this was like a hinge or something, you know, if there's a hinge here, you would draw moments there as well, and you would kind of just pick a direction. It really wouldn't matter. If you started doing math, you could figure out which way it was. You know, if it was negative, you just flip the moment then. But you have a moment saying that it can't spin. I guess it can't rotate around point A here. But yeah, free body diagrams. The biggest things you want to remember are you isolate the object you're looking at. So you want to isolate your object, and that's what you actually draw. So like here we technically have 3 objects, I would consider it, plus a force. So you want to isolate just the thing you want to analyze. So in this case, this cylinder, this rod, whatever you want to call it. So you want to isolate it, and then you want to identify, you can do it in either order, I guess. You can identify your forces acting on it or your constraints first. I identified the constraints first. So identify, and by constraints I just mean, sorry, forgot how to spell. Probably still didn't spell it right, but you want to identify your constraints, and by constraints I mean things that prevent motion. So in this case, preventing it from moving in the Y or the Z direction. You won't have to worry about any constraints on the X or rotating around the X axis, because it is allowed to do that, so you don't draw any forces for that. So yeah, identify constraints, and then identify outside forces like this. Like this force here, we have to draw that as well because that's acting on it. So you just kind of, the way I would like to think about it is if I was this beam, or this cylinder or whatever, what's acting on, what happens if I try to do this, and then just kind of analyze, if I move it up, down, left, right, can it do that? Like say, can I move in the X? Yes, there's nothing preventing it, because these don't prevent it from moving, from sliding, they just prevent it from translating. So like in this Y direction now, if it wants to come this way, it can't because it's stuck. Same thing with the Z. Rotating around the X axis is fine. Rotating around the Y or the Z is not, because of the way they are. So you just think about those things. So there's a moment there preventing that, there's a moment here preventing that. I didn't draw those super well, but you kind of get the idea that there's a moment here preventing it from rotating, there's a moment here as well. Preventing it from rotating around like this Y or the Z axis. The X is okay, obviously, because you can spin it. So then you identify any outside forces. Other forces. And the biggest thing with this is anything that prevents it from moving then in a free body diagram is now a force. So that you could solve for, say, this force, or if this force is acting here, what do these have to do to prevent motion? What's the magnitude of our moment? That type of stuff. So free body diagrams are super useful, and getting good at them is super useful for analyzing objects, especially static objects, because they're in a state of equilibrium if they're not in motion. So that means that everything is equal to zero. Your force is your moment, so then you can solve for things. So so if you knew this, you would be able to solve for all, some of these other forces. You may need a couple more knowns, but that's basically what a free body diagram of a rigid object is. Your first step is just to isolate the object you want to analyze, so this cylinder. Then you're going to identify your constraints. So this can't move, this can move in the X and Y, but it can't move towards me, like in the Y, or move in the X direction, sorry. It can't move towards me in the Y, and it can't move up in the Z, because these are preventing it. So then you draw those as forces, and then you think so this one there may not be a moment, simply because there's no pin here. I just drew that as an example. So if there was a pin here, there'd be a moment there, there'd be a moment there, also preventing it. With that pin, so if you have a pin on something like that, if you have like an object, there'll be, and say it could rotate freely, then you wouldn't have to worry about the moment because that's not constraining it. But you'll have a force here, you'll have a force here. Oops, actually it'll be like that. You have forces like that preventing motion too. Then, because if you have a pin on something, it can't slide, it can just rotate. So that's another way, just thinking about how things can move based on what they're connected to. And you just make sure it's one object and not multiple, because then things get confusing, and a lot of times they're just not right. Your free body diagrams, typically you isolate one object or kind of one collection of things that are all kind of having the same force on them. Like if you had an angled pipe, you could kind of pipe that ran like this through a couple different places. You could analyze that too and say what could happen with this, but just try to keep it to one continuous rigid object too. Yeah.